Hello everybody, my name's Andrew. Welcome to the channel. Today we're going to be talking about a fix to a problem using the default network transform in the MLAPI. The network transform is responsible for moving and syncing the position of objects between a client and a server and a client. You'll find that if you just put that on any object and then move it, you'll end up with this jittering problem that looks something like this. He's not walking very well on the client. Look at that. That shouldn't be happening. He's walking perfectly well on the server, but on the client he's like jitterbug. That's the server. You can see him walking around there, and this is the client. Now you'll notice that the movement of my little skeleton now is very smooth. There's no problems there. There's no jitter, and that's what we want to do. So let me show you how we did that. Okay, so in order to fix this problem, I'm going to introduce a concept that I'm calling a network anchor. I just made that name up. And what it is a way to hide that jitter that happens across the network. It's worth mentioning that I've removed completely the network transform, the default network transform, from my objects, and I'm only using this. So the way it works is basically you have your character, or whatever object it is that you want to move, and it follows what we call this network anchor. The player itself is only made up of the visuals, so it would be the model of the object that you're using. It wouldn't have a collider, and it wouldn't have a rigid body. And what we do is essentially we move the network anchor, which does have a rigid body and a collider on it, but it's invisible. We move this one, and then on the client we have the character smoothly catch up to that network object or network anchor. And that's pretty much it. That's pretty much the concept. So you've got this particular object that is following. It's following the network anchor, and the network anchor is the one that's jittering. This one's just smoothly following it, kind of like a rubber band effect. All right. So let's get into it and have a look how we did it. So this is the in our little diagram, we're talking about this component here. I've got the enemy network anchor. It's got a few things on it that are interesting. So one is the capsule collider. If we open the prefab, you'll see it's a typical capsule collider that you'd put on any object that you're moving around in the scene. It should be about the same size as the visual visual character that you're moving around, so about the same size as that one. We also have a rigid body on it, which is a standard rigid body. There's nothing interesting there. And we have the network anchor script, which is actually attached to this. Okay, so if we go to our skeleton object, which is the example that we're using, basically there's a couple of interesting scripts here that we want to look at. So you'll notice that there's no collider, there's no rigid body on this. So we're going to have a look at our firstly, the network anchor script. It's very simple. I add a name to it just so I know which sort of client or which object it's moving around according to. And I also take a reference to the whatever network behavior is following this network anchor. And I do that so that later on I can, as an enemy, I can choose to attack, different ones based on threat. Okay, cool. So the next one I have a look at is the client network anchor movement. So this is again is another very simple script. It's client only, which means if you're a server, you're not enabled. I pick up a reference to the network anchor itself, the network anchor body, and also this network character state that we saw before. And all I do is I take a position and a rotation from this network character state, and these are set on the server, which I'll show in a little bit. So I take the position and rotation of these network variables, so these are standard MLAPI network variables, and I apply them to the network anchor itself. So you see here I'm updating the transform position and rotation, and then I'm also updating the body's position and rotation. Okay, so once that's been set, this client network anchor movement has been set, I'll then go and update the visuals. So this is essentially the transform being updated on the client. So we're updating this one according to that movement. So the character according to the network anchor movement. I've got a couple of little checks in here. All this is doing is making sure we're above ground level, and this is also saying that if the velocity, the network velocity, which I also set on the server, if it's less than a certain amount, then I just set the network anchor's transform position to be the same as whatever the client is at the moment. So in other words, we're setting the movement to be nothing. And then all I do is I call this function called smooth move, and it will move the transform, so the transform of this particular object to the transform of the network anchor over a particular time and using a particular rotational speed. I've got a couple of those that are set up here. So the rotational speed is how fast you can rotate. And then the smooth speed is the minimum smooth speed at which the client catches up to the network anchor. And then I use this smooth move function. Now this particular function is within the sample API, the sample networking MLAPI boss room project. So if you have a look online, I'll put the link in down below, but basically it's doing it in a slightly different way, but this particular function is exact. I have not changed it one bit. So shout out to the boss room people on that one. And all it does is it takes a position difference and an angular difference and will update according to those parameters. So it'll just update the position and then also the rotation as well. And that's pretty much it for the client movement. So nice and simple. In terms of the server movement, all we're doing with the server movement is we're getting a reference to the local network anchor. So that's the network anchor on the server. Probably shouldn't have called it local. Network anchor body and this network character state as well. I've got some events that are firing on that state according to what the user does. So if the user presses forward on the or presses W, S, A, or D, it'll fire this event in the direction. Okay, and I've got functions that will just update these some of these variables up here. So rotate, direction, jump velocity, move velocity, and all the rest of it. Okay, nice and simple. Then all I do is a perform movement. So when we're performing the movement, we're performing it on that anchor. Okay, so it just moves that anchor around. So whether it's rotating, whether it's jumping, whatever it's doing, it's just updating the position and rotation of that network body. Okay. A few other little things here. Make sure I detach all my events later on as well. But all we're doing is as part of those events that are happening, whether it's the client or the enemy, we're just updating that network anchor. Okay, nice and easy. And the other little bit that is critical is that we also update, according to that network anchor, those network variables that I talked about a bit earlier. Okay, so the position and rotation, velocity, they all get updated so that they're synced across the network and then picked up by this client network anchor movement. Okay. So nice and simple. Yeah, if you have any questions, please leave them in the chat below. If you like the video, please like it. If you want to subscribe, that's great, because I'll be coming out with a few other videos around little problems that I've found and fixed. All right. Enjoy.